Let's start. If you want to know about me, then you can see from here. My name is Anup Kumar. I completed BTech. More than 4 years I have been teaching. There are some institute where I teach an academy target defense career, some local coaching also. So this is the first question. Integrate 1 upon x minus root x. Okay. So this is the integration of 1 upon x minus root x dx. So we need to let the root x is equal to t. So it's become minus 1 upon 2 root x dx is equal to dt by differentiation of root x. You know the formula of differentiation. X to the power n is equal to n x to the power n minus 1. Okay. So we can replace here. Now you can put here also minus 1 upon 2 root x is equal to t. You know this one is t. Dx is equal to dt. So dx is equal to minus 2t dt. Is it or not? And x root x is equal to t. So x is equal to become t square. Now you can replace here all values. So dx you can write minus 2t dt upon x become t and root x become t square and root x is equal to t. Now you can take the common t in denominator. It's become minus 2t upon t minus 1. Okay, dt. Now you can cancel out t and this t. It's become minus 2 in bracket in integration of 1 upon t minus 1 dt. Now this one is minus 2. When you differentiate the denominator and you get the numerator, it's mean this is the integration of log. Okay, log of differentiation. So the log of denominator, sorry, log of t minus 1, log of t minus 1 plus integration constant c. Now you need to replace t minus 2 log of t means root x. You let already replace root x minus 1 plus c. Okay, this is your integration. This one is second question. Integrate 1 upon 1 plus tan x. How will you do? First, you need to break the tan x into simplest form, that is sin x upon cos x. When you break the tan x into simplest form, sin x upon cos x, it's become cos x in numerator. In denominator, it's become sin x plus cos x dx. Okay, simply you can do it. This is integration. Now, what need to do now? So you need to multiply in numerator and denominator by 2 by 2. So you can take the common 1 upon 2 and multiply by 2 here. So now what you do? First you make the denominator in numerator as denominator given you need to make the numerator simply. So how you do it? 1 upon 2. Now you break the cos x, 2 cos x into, so it's become cos x plus cos x. You break the 2 cos x into cos x plus cos x. Now we need to make the denominator in numerator similar. So you need to add the sin x. When you add sin x, mean you have to subtract also sin x. Also subtract the sin x. Okay. Now it's become sin x plus cos x dx. Okay. Now it's 1 upon 2. Now you can break it. Now it can break into cos x plus sin x. Cos x plus sin x upon this sin x plus cos x. Okay. Again, in second term remains cos x minus sin x upon sin x plus cos x. Okay. Integrate of sin dx. So integration. So it will be 1 upon 2. Okay. This one, when you integrate, it's become first term. This one is cancel out, it's become 1, mean it's will be x. Okay. Yeah. Again, here in second term, when you integrate this, as I already told you, if any fraction written like numerator upon denominator, when you differentiate the denominator and get the value of numerator, then is the form of log of denominator. Similarly, it's occur here. There is no standard integration, but we need to make the differentiation of denominator. When you differentiate denominator, you get the numerator. Okay, is it or not? Yes. Sin differentiation of sin x is equal to cos x, and differentiation of cos x minus sin x. Yeah. So it's become log of sin x plus cos x. Okay. Plus integration constants. So this is your answer. By making a small bracket, you can write this also. Okay. Next one is, this is the integration of e to the power 2x minus 1 upon e to the power 2x plus 1. So how you do it? You need to make the common e to the power x. First, you need to take the common e to the power x. Integration of e to the power x. Take the common e to the power x. It's become e to the power x minus 1 upon, in denominator, e to the power x. It's become e to the power x plus 1 dx. So you can cancel out e to the power x, e to the power x. It's become e to the power x minus 1 upon e to the power x plus 1 dx. Integration. Okay. Yes. Now, what you do? Sorry. Here, sorry. When you take the common e to the power x, here it's become e to the power minus x. Sorry. E to the power minus x. Yeah. Here also e to the power minus x. This one. Yeah. So it's become e to the power minus x. Again, you can check, when you differentiate the denominator, you get the numerator. So it's a integration of log form. Means you can write log of integration of e to the power x plus e to the power minus x integration constants. Simply you can get this. Again, next question. 1 minus cos x upon 1 plus cos x. Integration. So first you need to remove 1 in numerator and denominator both. So by making the formula x by 2. Cos x by 2, you know cos x is equal to, cos x is equal to 1 minus 2 sin square x by 2, or 2 cos square x by 2 minus 1. So we apply both. In numerator, first 1 minus cos x is equal to, you can write 1 minus 2 sin square x by 2 upon denominator 1 plus cos x is equal to, you can write 2 cos square x upon 2 minus 1 dx. So here break the bracket 1 minus 1 plus 2 sine square x upon 2 upon, you can cancel out this one, this one. It's become 2 cos square x by 2 dx simply. Okay, so it's become integration of this one is also cancel out. It's become 2 sine square x by 2, 2 sine square x upon 2 upon 2 cos square x upon 2 dx. Okay, so these two cancel out. It's become tan square x by 2. It's become tan square x upon 2 dx. Okay, yes. So what you do? You know there is no standard integration of tan square x. So you need to break that tan square x into sec square x minus 1. So it's become integration of sec square x by 2 minus 1 dx. Okay, yes. When you integrate this, it's become 2 tan x by 2 minus x plus integration constants. This is your answer. Okay, integration of sec square x is tan x, but here is 2, so it's becoming multiply. Again, next, integration of dx upon x square minus 6x plus 30. Okay, so you can see this is the integration of type integration of dx of ax square plus bx plus c. So this type of integration first you do by making the complete square. So in denominator written here x square minus 6x plus 13. Okay, so you first make the complete square. It becomes x square minus 6x. It's become, you can write here 3 square 13. You can break 3 square plus 4 means 9 plus 4 means 2 square. Now you can see this one become x minus 2 whole square, x minus 2 whole square, and this one is 2 to the power of 2. Is it? Now see dx. Now you can replace denominator by x minus 2 whole square plus 2 whole square. Okay, so this is the integration of tan is integration of 1 upon x square plus a square dx. Okay, when you get this type of integration, you know this is the integration of tan inverse x upon a. Okay, so you can write here 1 upon a tan inverse, sorry, 1 upon a tan inverse x upon a. So it's become 1 upon a means 1 upon 2 tan inverse x means x minus 2, x minus 2 upon a means 2 plus integration constant c. This is answer. Very simple. Okay. Okay, next question. This one is, this is very good question. You can solve only by using the trigonometrical identity this question. Okay, how we can use the trigonometrical identity? First we know need to make 2 sine a into sine b. We know the formula of sine a into sine b, 2 sine a into sine b by cos a minus b minus cos a plus b. Okay, this form. So we need to make sine 4x into sin 8x in this form. So first we multiply in numerator and denominator by 2 by 2. So it's become 2 sin 4x into sin 8x. Okay, dx simply integration. So 1 upon 2. Now you can make in the form of addition. So it's become cos a minus b means 4x minus 8x. It's become minus 4x. Is it or not? Okay. Minus cos a plus b means 4x plus 8x is equal to 12x. It's become cos 12x. Whole integration dx. Okay. Now it's 1 upon 2 equal to 1 upon 2 integration of cos minus 4x. Cos minus theta is equal to cos theta you know. So it's become cos 4x minus cos 12x whole integration. Is it? Yes. So 1 upon 2 whole integration. When you integrate cos 4x, it's become 1 upon 4 sin 4x minus 1 upon 12. When integrate cos 12, 1 upon 12 sin 12x plus integration constants. Okay. If you didn't know, see here. If written here cos ax, you need to make the integration. So how you do it? You simply make the integration cos x. Let so you it become sin x. Sin x means you can write ax, and whatever you multiply in x you divide by a. Okay, so you can use in direct way. So there is a 4 in multiply of x, so you will divide by 4. Okay, next one is very important question. Yeah, you can integrate of x cube sine tan inverse x to the power 4 upon 1 plus x to the power 8. So how we can integrate this? Let tan inverse x to the power 4 is equal to t. Okay, tan inverse x to the power 4 is equal to t. So when we differentiate this, it's become 1 upon 1 plus x to the power 8 plus into 4x cube dx is equal to dt. Is it or not? Yes. So we can say x cube upon 1 plus x to power 8 dx is equal to dt upon 4. So now we can replace everything into t. X cube upon 1 plus x to power 8 dx is equal to dt by 4 means you can say 1 upon 4 here and dt. Tan inverse x to power 4, this one is t. It's become t. Okay, tan inverse x to power 4 is equal to t. It's become sin t. Yes, it's become sin. And whole thing you can this x cube power x cube upon 1 plus e to the power 8 dx is equal to dt. Okay, yes. So 1 upon 4 sin t, integrate sin t dt. So what will be the sin t? Integration of sin t, it's become cos t minus cos t. Okay, minus cos t plus integration constant c. So 1 upon 4, you can say minus here, 1 upon 4 cos t. T means tan inverse s to power 4 constant c. This is your integration of this. Okay. Thank you for watching the session. We'll meet in next video. Thank you.